All right, guys, so we're going to take a look at section 1.7, day 2, which has to do with something called function notation. So this stuff really isn't all that new. All it really is just a different way to notate or a different way to write stuff we've already done before. Okay, but what is function notation? Is a function rule is an equation that represents y values in terms of x values. Okay, all we're doing is we're just looking at different types of equations. Okay, in equations, you're usually going to see two different types of variables. You're always going to see an x. X is called the independent variable. Independent variable, and represents the input. Okay, x is what you plug in, and then y is the exact opposite. Y is called the dependent variable, which is what you get back, or we call the output. Okay, so why do they call it dependent variable? Because the value of y depends on what you plug in for x. Okay, so that's where that word depend or independent and dependent comes from. Independent, I can choose whatever I want to plug in. Dependent means it depends on what I plugged in for x. Okay, so here is the big takeaway for today. For the first, I guess, last 2 years of math, you guys have always seen equations written as y equals something times x plus another number. Okay, the example they're using here is y is equal to 3x plus 2. Okay, as we get into higher level math classes, they'll start getting rid of y and replacing with other types of notation. This is called function notation. Okay, if you see f parentheses x, that is not f times x. Okay, this is actually read as f of x. Okay, f parentheses x is read as f of x, or the function f of x. It is no different than this guy over here. It functions exactly the exact same thing. Okay, f of x is the exact same thing as y. Now, where this comes in handy is another notation you'll see is if you see f parentheses 1. Okay, so what that means is you're going to use this original equation exactly as it was given to you, but wherever you see an x in the original equation, you'll plug in whatever is inside your parentheses. In this case, it's 1. So if you see f of 1, you plug in 1 in for x into that original equation. Okay, so let's do some examples. It says if f of x is equal to 6x plus 7 and g of x is equal to x squared minus 4. Find each value. Okay, so for example A, they're asking me to solve for f of negative 3, not f times negative 3, f of negative 3. So they give us two different equations. They give us an equation called f, which is 6x plus 7, and they give us an equation called g, which is x squared minus 4. Okay, so for example A, we're trying to solve for f of negative 3. Okay, because I see the letter f, I know I'm using that first equation. Okay, and if I want to solve for f of negative 3, what that means is I'm going to rewrite this equation, but wherever I see an x, I'm going to plug in a negative 3. So I'll rewrite it. F of negative 3 is equal to 6 times negative 3 plus 7. Okay, all I did is I substituted in negative 3 for x. And I just solve it like I would any other type of equation. F of negative 3, 6 times negative 3 is negative 18. Negative 18 plus 7. F of negative 3 is equal to negative 11. Negative 11 is my answer here. Okay, so all I did is I saw the letter f. I knew I was looking at this first equation, and I saw of negative 3. So I plugged in negative 3 for x, and then solved and simplified. Okay, now if we look at letter B, it says f of m. Okay, the first letter I see here is f, so I know I'm dealing with the equation that is called f of x. And what I need to plug in here is the letter m. So all I'm going to do is I'm just going to rewrite that f equation, but wherever I see an x, I'm going to plug in a m. So when I rewrite it, it just becomes 6. Instead of x, I write m plus 7. Now there's not really any other way I could simplify that, so this is my answer in simplest form. All I did is I substituted the x for an n. Okay? Hopefully we're feeling okay so far, nothing too complicated. For the next one, I see, for example, C, it's f of r minus 2. Okay, so if I want to solve for f of r minus 2, once again, I'm using the equation f. And wherever I see an x, I'm going to plug in an r minus 2. So let's rewrite it. I still got a 6, but instead of x, I'm going to plug in r minus 2. Super important you include those parentheses. And then I still got the plus 7 at the end. Let's go ahead and simplify this. The 6 distributes. 6r minus 12. Still got the plus 7 at the end. Simplify, negative 12 plus 7 should give me 6r minus 5 is my answer. Okay, so the only difference here is it doesn't really matter. This time I had two different terms. Wherever I saw an x in that first equation, I plugged in an r minus 2. Okay, so for the next one, I see g of 5. This is the first time we're introducing the g equation. So the g equation was x squared minus 4. It's the exact same logic. Wherever I see an x in that first equation, I'm going to plug in a 5. So if I want to solve for g of 5, it'll be 5 squared minus 4. Simplify this a little bit. 25 minus 4 should be equal to 21. Okay. So the only difference with this one is instead of the letter f, I wanted you to solve for the function g, plug in 5 in for x. Okay, so this one's a little bit different. We've got g of a plus 9. Okay, but the first thing I do see is that g of a. So I'm using my g of x equation, but wherever I see an x, I'm going to plug in an a. So what I'll have here is I'll have a squared minus 4. Okay, that's what happens when I plug in a for x, but in here I still need to add 9 at the end. Okay, so I got g of a, which is a squared minus 4, and then I have to add another 9 to that. Okay, simplify this a little bit. I should have a squared minus 4 plus 9. Negative 4 plus 9 is equal to 5. It should be a squared plus 5. And the last one, g of negative 4t. Okay, the function g, I'm using that second equation. I should have, if I'm solving for g of negative 4t, it should be negative 4t squared, super important you got that in parentheses, minus 4. Okay, sorry, I'm towards the edge there. Okay, super important, exponent rules do apply here. The squared does go to both terms. It should be negative 4 squared becomes 16. Should have a t squared, and then a minus 4. G of negative 4t. This is my answer in simplest form. 16t squared minus 4. All right, we'll do the last couple real quickly here. So for example, G, it says f of q plus 1. Okay, first letter I see here is the letter f, and I need to plug in q plus 1 into that f equation. So what I'll have here is I'm looking at the orange equation, and wherever I see an x, I plug in a q plus 1. Parentheses do matter. And I have a plus 7. Go ahead and simplify this a little bit. Distribute the 6. Should be 6q plus 6 plus 7. And then you can combine like terms here. Positive 6 plus 7 should give you positive 13. So f of q plus 1, all I'm doing is writing this in reverse order. F of q plus 1 is equal to 6q plus 13. Okay, for letter H, it looks like we're combining these two functions, the orange and the green. So we got f of 2 plus g of 2. So what that means, all I'm going to do is I'm going to plug this 2 into the f equation and this 2 into the g equation, and then squeeze the two things together. So when I plug in 2 into the f equation, I should have 6 times 2 plus 7. And then I'm adding, when I plug in 2 into the g equation. I'll have 2 squared minus 4. Okay, so do a little math and simplify. 6 times 2 is 12. I'll change colors once again. 6 times 2 is 12, plus 7, plus 2 squared, which is plus 4, minus 4. 12 plus 7 is 19, plus 4 minus 4 is 0, 19 plus 0, 19 should be my answer here. All I did is I plugged in 2 into the F equation, G into the 2 into the G equation, squeezed them together, and then added them. And then the last one is letter I, G of negative B. Okay, I see the letter G, I use the G equation, I'm using the green equation. Let's rewrite it. G of negative B equals, in parentheses, negative B squared minus 4. What can happen here is this 2 distributes to the negative and to the B. So when you square negative 1, it just becomes 1. And then when you square B, it becomes B squared. You should have positive B squared minus 4 as my simplified answer. Okay, and then for letter J, it asks what type of function is f of x and what about g of x? Okay, so if you look at these two types of equations, we'll keep it real basic right now. F of x follows the format mx plus b. That's a number times x plus another number. Okay, anytime you follow the format mx plus b, this is called a linear function. If you were to graph that orange function, it would come out as a straight line going up and to the right. Okay, we haven't spent much time with equations that look like the green one, x squared minus 4. But what we do know is it doesn't look like mx plus b. So f of x is linear. I'll make that more clear. F of x is linear, but because g of x doesn't follow the format mx plus b, we'll say g of x is nonlinear. When we graph it, it's not going to look like a straight line.